For the past 3.5 years, WIT Services has serviced Osborne computers for people virtually all over the world. The Osborne Survival Kit is a continuance of that service. Some of the repairs require no parts. However, if parts are needed, give us a call to find out if we have them. Outside of Illinois, dial 800-334-7506. To order a part inside Illinois, dial 312-PC-CLONE. Two other reliable parts sources are Mission Peak Systems in Fremont at 415-490-5003 and Warswick Industries in San Diego at 619-571-5400. Please remember that our 800 number at WIT Services is not for technical support, but for orders only. We hope you enjoy the Osborne Survival Kit, and we'd like to hear your comments. Thank you for your order. I'm Mark Witt. We've put the section on cleaning your disk drives up front because most of the drives we service have been abused by improper cleaning. Here's William to tell you how to properly clean your drives.
Hi, I'm William Witt, and I'm going to show you how to properly clean your disk drives. To clean your drives, you will need a disk drive cleaner kit. Most disk drive cleaner kits look like this one. Notice the silver label on the disk drive cleaner jacket. This label must stay in place when you're cleaning an Osborne drive. I'll explain why in a minute. This package contains a cloth disc soaked in alcohol. Open the package and put the disc in the jacket. You can buy these disk drive cleaner kits at WIT Services. Notice the cloth shows through on only one side. The side must go towards the read-write head on the disk drive. The Osborne disk drive, the read-write head is down. Place the disk drive cleaner in the Osborne drive. We've removed the disk drive so you can see better. I believe the disk drive would remain in the Osborne. After you put the disk drive cleaner in the disk drive, boot the disk drive by pressing return. If you are cleaning drive B, press the tab key instead. If we remove the disk drive electronics, you can see inside. Once again, we can see the silver label. This side of the disk drive, which is the top, you can see the load pad. The read-write head is opposite of the load pad. If we put the disk drive cleaner in upside down, we would ruin the load pad. It's very important that the disk drive cleaner is put in the right way when you're cleaning an Osborne disk drive.
Next, we'll discuss basic disassembly and reassembly of an Osborne 1. For routine disassembly, repair, and reassembly of an Osborne 1, you'll need a set of basic electronics hand tools. For many repairs, you'll need only a Phillips screwdriver. The Phillips screwdriver must have a 4-inch shaft. so that it can reach the screws deep in the wells of the Osborne case. You'll also find a pair of needle nose pliers handy. The needle nose pliers are the best tool we found for removing the knobs off of an Osborne 1. For adjusting disk drive speeds, you'll need a flat-bladed screwdriver. And for removing RAM chips, keyboard connectors, and replacing them, you'll need a pair of diagonal cutters, a high-quality soldering iron, and solder. In addition, you may need parts. Begin disassembly by removing the power cord and the keyboard. With the needle nose pliers, grasp firmly the knobs on the front of the Osborne. Pull quickly and steadily back. The knobs should come free. Next, with the Phillips screwdriver, remove the screws holding the fascia to the case. There are 6 of these screws, 1 in each corner, 1 top center, and 1 in the center on the bottom. If the screws seem to turn too easily and never come loose, it may indicate that the brass nuts or bosses that were embedded in the case have come loose. After loosening all the screws, remove the fascia from the case. If this were an 80-column unit, there would be a cable attached to the 80-column board in this location. You would remove it from the 80-column board before pulling the fascia away. Now, turn the fascia over to remove the screws. Collect the screws and put them in a place where you'll be able to find them later. All of the screws holding the Osborne case together are attached through the bottom. Turn the computer over on its top. With the Phillips screwdriver, loosen the screws but do not remove them. There are 5 of these screws buried deep in a well. By not removing the screws, we run less risk of losing them and of putting 2 screws in one hole. A little shake will loosen the bottom of the case. Remove the case bottom and the handle and set them aside in a place where you won't step on them. The green board on top is the logic board or system board. It is secured to the case by metal brackets. It is possible to remove the brackets or to just remove the system board from the brackets. Either way is acceptable. It is our policy in the shop here to just remove the system board and leave the brackets in place. As you remove the screws, be careful where you put them. If you set the case on top of the screws, the star washers on the screw can cause a deep scratch in your computer case. The computer board may be lifted carefully. It will still be attached to the cables along the back of the computer case. This is the power cable, and this is the disk drive cable. If you have a double density machine, you'll also find a 2x3 board setting right in this location. Note the orientation of all of these connectors. Countless machines have been brought in for service that had nothing wrong with them but the connectors on wrong. This connector goes to the internal monitor, the 5-inch CRT. Usually the plug is red. The black shunt on the front wraps the signals from the bottom of the board to the top of the board. If this video shunt or a monitor adapter is not in place, the internal monitor will not work. If you don't use your internal monitor, you may wish to unplug it right here to save the extra heat that it creates. Of course, means you would have to remove the fascia to plug it back in. If you need to turn it on occasionally, you may be interested in a product that we have here at WIT Services called Monzap. On most systems with a serial number over 8000, all connectors are used on the power plug. In this case, the plug is actually reversible with no effect to the computer. However, if it's an early machine, you must be careful not to put the plug on backwards. Look closely at the disk drive cable. Note that the red stripe is towards the center of the system board. Before removing the connectors, you may wish to mark an arrow on the board and on the connector indicating which way the connector goes on. Remove the system board and set it aside to a safe place. While we are going to show you how to remove every major component of the computer, we do not recommend removing anything that's not necessary. Remove the chassis from the top of the computer. Note that there is a dull metal finish to the entire inside of the case. This metallized paint is used to reflect radio frequency interference. Scratching the paint can reduce its effectiveness. We have seen some cases without the paint entirely. Each of the major components of the Osborne computer, the drives and the monitor and the power supply, are secured with only 4 screws. We will be removing the A drive. Remove the 4 screws that secure the A drive to the chassis. Sometimes the screws may be difficult to get out of their holes. An additional twist to the screwdriver may remove the screw. Move the drive to the side and disconnect the grounding wire that is attached. Some systems do not have this grounding wire. The disk drive cable is removed, exposing the disk drive card edge. The card edge is a 34 conductor. Note that the red stripe is towards the outside edge of the disk drive. This is always true with an Osborne drive. The internal monitor is secured to the Osborne 1 with 4 632 screws. In most of the units we see here at WIT Services, all of the retaining screws are of the same length. However, in some early Osborne 1s, shorter screws were used to hold in the monitor to avoid damage to the circuit board. Make sure that if the screws that hold in your monitor are shorter than the ones holding in the drive, that you reuse them for the monitor. Next, lift and separate the chassis from the internal monitor. Disconnect the grounding wire if one is present. If only one grounding wire is present in your system, it should be connected to the internal monitor. The monitor is covered with a heavy metal or copper foil shielding. The shielding keeps radio frequency interference from interfering with your disk drives. The power supply should have been disconnected at least a half an hour before you began your operation. Power supplies retain voltages in capacitors which can cause severe discomfort to your person. The power supply is insulated from the logic board with this mylar covering. This mylar covering must be replaced when you reassemble your computer, or you could cause damage to your computer and your power supply. Begin removing the power supply by disconnecting the screws that hold the mylar insulator in place. On the opposite corners, 2 more screws attach and ground the power supply to the computer case. Remove these screws. Place all screws in a safe place where you'll find them later. The power supply may now be lifted out of its cage. If the system was not turned off for at least a half an hour before you began your work, avoid touching the tops of the capacitors and any other metal parts. When reassembling the system, install the monitor first. Flex the chassis a little bit and place it over the monitor. Slide the monitor and its shielding into place so that all 4 holes line up. Secure the monitor with 4 screws. Once again, if the screws used to hold the monitor in were shorter than those to hold the drive in, be sure and use the same screws. This is especially appropriate with black and white monitors. The grounding wire must now be attached. This grounding wire is important to the performance of your machine. Place the A drive in the slot directly over the power supply. The only difference between the A drive and the B drive is the resistor pack in the A drive. You may change the B drive to an A drive by simply moving this resistor pack to the B drive. Attach a grounding wire to both A and B drives if one is available for each. Some systems have only one grounding wire, which should be attached then to the monitor. Install the disk drive cable. Install the connector closest to the end connector in drive B. As you reinstall the drive cable, check for nicks and cuts that may cause a short, and be sure to keep the red stripe towards the outside edge of the disk drive. Press the connector firmly onto the card edge. Sometimes it may feel like the connector is in, but it really isn't. Double check your connections. There are 4 connections you will need to make to your power supply, aside from the connections going to the logic board. Replace the green wire to the grounding lug, the 2-wire connector to the 2-terminal plug just to its left, and the 2 loose blue wires to the terminals marked 115 and 230 volts. These 2 blue wires with the black boot on the end are virtually interchangeable. After all 4 connections are made, replace the power supply in its cage. This aluminum cage helps keep radio frequency interference from affecting the performance of your A drive. However, sometimes a deteriorating or defective power supply will affect the A drive. Replace the 2 screws holding the power supply to the case. Replace the insulating mylar piece. Insert 2 screws in opposite corners. And tighten them. Some units may have been shipped without this mylar insulator. You can make your own mylar insulator if you do not have one. We also have them in stock. The disk drive cable must be put back in its clips. These clips are located on the back of the monitor. These clips help keep the cable organized. Next, replace the chassis into the top of the computer case. The 5 pylons extending from the top of the case mate with the 5 screw holes in the chassis. One of the most common errors a technician unfamiliar with an Osborne will make is not putting the drive harness in its clips. The probable result of this error is that a screw may be driven through the cable during reassembly. Replace the AC power panel at this time, but do not attempt to replace the door. The door is best replaced after final assembly is completed. As a matter of fact, if you don't travel with your Osborne, you may wish to consider leaving the door off. Make the connections for the disk drive and the power supply. The disk drive connector must be oriented so that the red stripe is towards the center of the circuit board. Reconnect the video monitor. A common error here is to put the connector on with everything over 1 pin. While this doesn't hurt anything, it doesn't work either. If there was a mylar insulator located near this power connector, replace it. We've seen no ill effects from them not being present. Resecure the system board with 4 screws. Next, replace the handle, or, if you've chosen a fan for your system, insert the fan. We have these fans available. The handle can be put in upside down, and it almost fits, but not quite. So check to make sure that everything lines up properly. Replace the case bottom. The screws should still be in the case bottom. Sometimes a little vibration is necessary to cause the bottom to mate with the top. Tighten each of the 5 screws holding the case halves together. The screw is actually being tightened into a brass boss, which is embedded in the plastic case. Over-tightening the screw into this brass boss will cause it to turn and, eventually, fall out of the case. Do not over-tighten any of the screws in the Osborne case. Next, we'll replace the fascia. A most common error in replacing the fascia is forgetting to bring the clips on the keyboard connector forward. These clips must be brought forward or they could be broken off. Slide the fascia into place, vibrate it a bit to make it seat. Secure it with the 6 screws. These 6 black anodized screws do not have a star washer. Next, replace the video, contrast, and brightness knobs. The system is now fully assembled, with the exception of the keyboard and the AC power connection. Instructions for creating a working bootable copy of the factory diagnostics are in readme.doc on the Diagnostic diskette. You may choose to rename the file osborne1.com to autost.com, which will cause it to boot when you press return. The first A through F tests are for memory. We recommend running E, Run All Memory Tests. Some errors in memory will show up after one cycle of the refresh test. However, others may take as much as 8 or 10 hours of constant testing and heat from the computer to show up. The grid in the memory test section is a direct representation of the memory grid on the circuit board. Notice the letters and the numbers on the circuit board correspond to the numbers and the letters on the memory test screen. If a 1 appears, as it has here in 21C, this indicates that a RAM chip is failing. Write this C21 down so that later on you can mark the chip to be removed. Tests G, H, and I test the functionality of your disk drives. Be aware that these tests destroy any data on any diskettes in the system when they are run. Use 2 brand new blank unformatted diskettes to run the drive tests. To run the port tests J and K, you'll need a loopback for the serial and parallel port. These may be purchased from Warswick Industries, Mission Peak Systems, or WIT Services. The drive exerciser is entered by selecting P from the main menu. It gives us a handy way to check the drive speed without disassembling the computer. The drive speed is given in milliseconds. Ideal drive speed is 200 milliseconds or 300 RPM. The exerciser can also be used to step the drive to a specific track when using an oscilloscope and alignment diskette to align the drive. While this tape does not cover alignment of drives, we'll be happy to supply you with documentation and technical assistance. While menu selection S gives a pattern that could be used for adjusting the internal monitor, we do not recommend that you try this unless you are experienced. Lethal voltages exist inside of a working internal monitor. The next section is for errors. Sections V and W will tell you the result of your disk drive test. If numbers appear in any of the columns, make a record of those numbers for future reference. A most critical factor for drive performance is its speed. Set up your system partially disassembled with the drive electronics accessible. Drive speed is adjusted by the blue potentiometer located on the drive electronics. You may adjust the drive speed while watching the Disk Exerciser program. Drive speed must be 200 milliseconds plus or minus 2 milliseconds for double density or 5 milliseconds for single density. You may also adjust the drive speed by watching the wheel turn under fluorescent light. When the bars appear to stand still on the outside ring, you have reached 200 milliseconds. It is critical that the pulley belt linking the spindle hub and the spindle motor be tight. When you press on the spindle hub, you should be able to stall the spindle motor. If pressing on the hub does not cause the spindle motor to stall, the pulley is too loose. As a stopgap measure, you may be able to turn the belt inside out or roll it 180 degrees and reinstall it. This, however, is only a temporary measure. Sometimes it doesn't work. But even if it does work, you need to find a new belt. Belts tend to slip more as the machine warms up. This accounts for some problems that seem to come only after the machine is on for an hour or two. This particular turning of the belt had no effect. You can see how much extra tension is required to stop the motor. There is, unfortunately, no way to move the spindle motor further away from the hub. Contact your supplier for availability of disk drive belts. The Osborne Executive and Osborne One keyboards are identical and easy to replace. Here's Daniel to show you how.
I'm Daniel Witt, and I'm going to show you how to change a keyboard. To change a keyboard, you'll need a screwdriver, Scotch tape, and a new keyboard. There are two kinds of keyboards, and we will be showing you the installation of an oak keyboard. The keyboard case halves are held together by 4 screws. After loosening the 4 screws, separate the keyboard halves. Before removing the connector, place a piece of tape on the side of the connector nearest the number row. This will help you get the connector on correctly later. Now remove the keyboard cable connector. Next, remove the ground wire. Now remove the additional 3 screws that hold the keyboard to the case. Remove the keyboard and throw it away. Oak keyboards are not repairable. Insert the new keyboard in the keyboard case. Next, reconnect the connector. Make sure that the tape side goes nearest the number row. Next, attach the screw that holds the ground wire if you have one. Some keyboard cables do not have a ground wire. This is okay. Next, attach the keyboard with the additional 3 screws. Next, reattach the case parts and tighten the 4 screws. Now we will show you the differences between the oak and TEC keyboards. The only difference when installing a TEC keyboard is that the connector goes in the middle here, and the ground wire, if there is one, goes here.
We've often said that we could have just about started our business repairing only the Zenith monitors and Osborne 1 computers. We've fixed a lot of them. The symptoms of the most common monitor problem in an Osborne 1 are jitters. Sometimes it's difficult to even notice at first. Eventually, the screen will collapse into one thin line and disappear altogether. The source of this problem is cold and broken solder joints on the circuit board inside the internal monitor. I've seen this problem also in a Zenith computer and a microterm terminal with circuit boards nearly identical to the one in the Osborne 1. I've also seen the same part number labeled Q103 fail in Zenith monitors. There were 3 monitors used inside the Osborne 1. The first monitor shown here is a black and white monitor. The monitor was manufactured by Motorola. You can tell the monitor, aside from it being black and white, by its silver chassis. These monitors have proven very reliable. The second monitor type is a green screen. It appears to have been made in Japan, possibly by Matsushita. This is the Zenith monitor. Be aware that all monitors can retain high voltages for up to half an hour after the system has been turned off. In addition, there is danger of breaking the picture tube. If the picture tube were to break, it would implode and throw glass at high speeds. The source of the problem in the Zenith monitor is the transistor located inside this heatsink. To repair the problem, you'll need a high-quality soldering iron, some electronic solder, and if the problem is going on too long, you may also need a replacement transistor, available from any Zenith parts supplier. If you look very closely at the back of the transistor, you'll see 3 contacts. These contacts sometimes have a black ring around them. This is an actual separation of the transistor from the circuit board. We will need to add solder and reconnect the transistor to the circuit board. If you've never soldered before and you would like a circuit board to practice on, give us a call on the technical line and we'll send you out a circuit board for $2 to cover our freight and handling. Be careful not to accidentally connect the terminals of the transistor. Check all along the back edge of the circuit board. You may find additional cracked joints. This particular joint is also frequently cracked. The opposite side on the circuit board connects to a blue wire. Sometimes the circuit board has to be completely removed. When reconnecting the video harness, there may be a key in this position. In any event, you'll notice a number 10 on one end of the connector and a 0 on the circuit board near the slot. Mate these together. We mentioned earlier that a monitor can retain high voltage for periods up to a half an hour after disconnection. This voltage is generated by a device called a flyback. Because these voltages may be as high as 25,000 volts, we do not recommend that you make any internal adjustments with the monitor on. The single largest shortcoming of an Osborne 1 was its 52-column display. For that reason, ScreenPack was a very popular upgrade. There are some of these still available through the 3 major suppliers. ScreenPack consists of a circuit board, a 14-conductor harness, a power connector, and a video connector. 2 wire wrap spacers are also sometimes supplied. To install the ScreenPack, you'll need a 27 or 33 watt soldering iron and solder. There were 2 separate ScreenPack boards sold. If you have a board like this one with a long black coax cable, give us a call and we'll tell you what to do. Your system board may be one of 2 versions: a multi-layer board, which has a metal stripe running all along the front edge, or a 2-sided board. The 2-sided board can also be identified by its translucence. While the 2-sided board is an older version of the Osborne logic board, it can be electronically identical. If you have a multi-layer board, there is no question as to the upgradability of the logic board. If you have a 2-sided board, there are 2 factors you must check for. One is the revision letter of the board. The board must have an indicator of G or higher. And the sockets on some 2-sided boards were made by AMP. The AMP socket was designed to hold an LSI and does not hold wire wrap pins very well. The pins on the bottom of the 80-column board are known as wire wrap pins. They must be inserted into a socket that has more generous holes. If your board is upgradable, proceed by making labels for each of the chips to which you will have to solder. Label these B11, B16, D14, D16, D17, D18, E13, and E22. These labels should be small enough to fit on top of an IC. Note on your logic board that each row is marked with a letter, and each column is marked with a number. Begin by locating the chip B11. Place the label on top of B11. Continue this process until all of the labels you have created are on top of the appropriate IC. In addition to locating the proper IC, you'll also have to find the proper pin number. And one of the most common problems in installing your first ScreenPack will be counting the pin numbers. This is pin number 1, located near the white dot. The pins are counted down and then jumping directly across and up, counted in the shape of a U. This is pin 16. Double check that you have properly labeled the chips. To minimize the amount of heat that is applied to the chip, it is important to tin the ends of the wires on the harness. Do this by heating the wire and adding a bit of solder. Before beginning installation of ScreenPack, tin the leads on all 13 of the wires. One of the wires is missing. Next, tin the lead on the chip. You may do this as you go, or you may wish to review the tape and tin the chips in advance. If you get a little overzealous when tinning a chip, you may actually connect 2 pins on the chip, like this. If this happens, you'll need a solder bulb. These are available from any Radio Shack. Heat the solder and suck it into the solder bulb. In referring to the numbers of the wires, we will refer to the yellow wire on the harness as number 1 and the brown wire on the end is number 14. We have pre-tinned the pins. Connect gray wire number 7 to B16 pin 1. Give a gentle pull on the wire each time you connect one to make sure that it's secure. Next, connect blue wire number 9 to B11 pin 12. Connect the orange wire number 12 to D14 pin 5. There are 2 orange wires, and the orange wire is easy to confuse. It is a source of a lot of problems. Connect red wire number 13 to D16 pin 4. This should be the only red wire long enough to be accessible. Connect brown wire number 14 to the same chip D16 pin 5. Next, connect yellow wire number 11 to the same chip D16 on pin 2. Once again, these legs have all been pre-tinned. Connect green wire number 10 to pin 14 of D17. Purple wire number 8 to D17, pin 13. White wire number 6 to D17, pin 12. And finally, for chip D17, attach the brown wire number 4 to pin 11. Orange wire number 2 is attached to D18 pin 14. Always double check the orange wires. Yellow wire number 1 is attached to E13 pin number 1. There are 2 yellow wires. Check to make sure you have the right one. Chip E22 has only 14 legs, and finding pin 12 to attach black wire number 5 is a little different than finding pin 12 on the other chips. Protect the end of the connector from being bent or broken. Next, remove the Z80 and the character generator ROM with a flat-bladed screwdriver or a chip pulling tool. If you're using a flat-bladed screwdriver, gently pry each end of the chip and set it aside. Next, remove the character generator ROM in the same manner. Be very careful not to pry on the socket. The character generator ROM has the insignia Rev A. Turn the 80 column board over and install the wire wrap spacer on the 40 pins opposite of the Z80 socket. The wire wrap spacers help to keep the pins straight as they're inserted in the system board. Do the same for the 24 pin. Turn the board back over and install the character generator ROM in the appropriate socket. Note the notch in the socket and the notch on the end of the chip must line up. All 24 legs must be inserted firmly. Next, install the Z80 in the Z80 socket, noting the same orientation marks the notch on the chip, and a notch on the socket. When all 40 pins are in, gently press on the Z80. The screen pack is now ready to install on your system board. Place the screen pack over the Z80, the character generator ROM sockets, and over the video connector. Press the 80 column board gently onto the video connector, and if all of the pins are lined up, the 80 column board should gently press into place. Next, install the 14 pin connector, making sure that no pins are bent up or broken off. Install the power supply connector. The video connector does not need to be installed now. However, when it is installed, the ground wire goes towards the back of the computer. And even though there are two connectors on the front, P1 and P2, only P2 is appropriate for the internal monitor. After installing Screen Pack, an external monitor adapter is not necessary, and if used, will give exactly the same effect as using P1 on the 80 column board. The screen will be unreadable. Next, you will need to drill a 1/4 inch hole in the fascia. A measuring template or diagram should have been included with your screen pack. If it wasn't, give us a call and we'll help you find the proper place. Install the RCA connector through the front of the fascia. Place the ground ring over the RCA connector through the back and secure it with the nut. After getting the nut finger tight, finish tightening it with an end wrench. After it's tightened, insert the terminal connector onto the back of the RCA jack. Next, reconnect your system board to the Osborne. Note that the red or blue stripe must be towards the center of the system board. Connect the power supply connector and replace the insulator if one was present. Next, hook the power lead from the 80 column board into the power supply and reinstall the internal video monitor. Reassemble the computer following the disassembly section instructions. Keyboard connectors on an Osborne are frequently broken. Once a pin is accidentally bent and straightened back into place, it will probably break on the next bend. A missing keyboard connector pin will cause the keyboard to malfunction by shutting off several keys. To replace a broken keyboard connector, you'll need several tools: diagonal cutters, needle nose pliers, a new part available from all three major parts suppliers, solder, a solder bulb available from Radio Shack, and a high-quality soldering iron, no more than 33 watts. This is a difficult repair and should be attempted only by experienced technicians or hobbyists. The keyboard connector is retained by 20 different pins. For this reason, we have found it preferable to cut the keyboard connector into little pieces so that the pins may be removed one at a time. This is somewhat dangerous as plastic parts go flying about the room. Do not have anyone else in the room when you work, and we recommend wearing safety goggles. Be careful not to gouge the circuit board with the ends of the diagonal cutters as you cut the keyboard connector plastic. This job will take about 5 to 10 minutes. We've compressed the job a bit here on tape. After you've cut the plastic into pieces, you may find that a pair of needle nose pliers can be useful for pulling them out from between the pins. Take your time when doing this operation. There's no need to hurry. and hurrying can cause damage to your system board. We've tried taking them out by removing the solder from all 20 pins, but this system seems to be more consistently effective. After you have removed the plastic from the keyboard connector, you'll have 20 separate pins that may be removed one at a time. Mount the logic board vertically in a vise. We use a drill press vise at WIT Services. Any vise will do, as long as it doesn't scratch or mash any of the components on the circuit board. Next, heat the holes from one side and remove the pins from the opposite side. Heat the solder before you grip the pin. Gripping the pin first will cause the needle nose pliers to act as a heat sink and dissipate heat from the pin, causing the solder to melt more slowly. Removing all the pins should take a while, perhaps 10 or 15 minutes. Take your time. Do not use an excessively hot soldering iron. Very hot soldering irons will remove trace from your circuit board. Now you must remove the solder from each hole. A solder hole that is only half full of solder is difficult to suck dry. It may be necessary to fill some of the holes with new solder, so that when applying heat, all of the solder in the solder hole will melt. Again, apply heat from one side, remove the solder from the other. You will find it necessary to periodically clean the solder from the solder bulb. Once each of the 20 holes is empty of solder, insert a new part. You will notice that the upper left-hand hole is empty. Some Osborne parts had no pin here. This is not a problem. It is noteworthy that the lower left pin on the keyboard connector and the upper right pin on the keyboard connector may be missing on an Osborne keyboard connector. Apply a small amount of solder to each of the 20 pins. Do not apply excessive amounts of solder. Excessive amounts of solder can accumulate on the other side of the board, hidden from view, and causing a short between two pins. If you do this repair yourself, you can take some satisfaction in knowing that a major national computer service organization quoted this job at $650 3 years ago. If the diagnostic memory test indicates that you have a bad RAM chip, the RAM chip can be repaired by you or someone you know who has some technical experience. This process is very much like the one described earlier in removing a keyboard connector. Have everyone else leave the room and wear protective eyewear. The RAM chip is going to fly about as you cut it into pieces. People who have worked on computers for years have a habit of trying to save chips no matter what they're worth. These chips that you are cutting out used to be worth $10 or $15 a piece. Currently, they can be purchased at most Radio Shacks for well under $1. If you have trouble finding a 4116 memory chip of the proper nanosecond rating, give us a call and we'll help you out. We also have boards that you can practice on. These are totally defective boards of no value. For $2 for freight, we'll send you one and you can have some practice before you go at your logic board. Removing all of the plastic or ceramic from a RAM chip should take a little less time than a keyboard connector, perhaps 5 minutes. but take your time, don't rush the job. Next, mount the logic board vertically in a drill press vise or a regular vise as described in the keyboard connector section. Heat each of the pins from one side of the board and remove it from the opposite side with a pair of needle nose pliers or long tweezers. Melt the solder thoroughly before attempting to grab the pin. The needle nose pliers will act as a heat sink and cool the solder down. There are 16 pins on a RAM chip. After all have been removed, heat each hole from one side and suction the solder from the other. You may find it necessary to add solder to the hole so that adequate solder will be present to melt all the solder in the hole and allow complete evacuation. After all of the holes have been cleaned out, insert a new RAM chip of the proper nanosecond rating. It should be of the same nanosecond rating as the other chips on the board. Be careful of the orientation of the chip. Solder one pin on each corner of the chip. This will keep the other legs in place for soldering later. Add solder to each of the 16 pins, and you're finished. Avoid excess heat to the pins, and once again, do not use a soldering iron over 27 to 33 watts. If you need more technical information, details of schematics, and so on, you will be able to purchase that from WIT Services Incorporated. We have the Sam's computer fax and can supply you with documentation from the technical manual as needed. We also have printed and illustrated instructions for installing the 80 column board. If you need those, all that we ask is that you pay the postage. This concludes the Osborne Survival Kit. We hope you've enjoyed it. Thank you. The last 2 minutes of the tape have excerpts from Building and Upgrading XT Clones. Building and Upgrading XT Clones was WIT Services' first video production. It shows the process of building an XT-compatible computer from the case up. The video is straightforward and can be used by persons not only building an XT clone, but also by persons adding a second hard drive, a second floppy, or just wanting to know what's going on inside of their IBM-compatible computer. WIT Services also repairs and sells XT clones. In Chicago, our new phone number is 312-PC-CLONE. 759-5780 is still active for us. If you have an interest in building and upgrading XT clones, give us a call. The price is only $29.95. Thank you. I'm Mark Witt.